Okay, so this is the demonstration of the marine debris classifier using an API and a public deployment of the service. So for this, I used Flask and Google Gemini 1.5 for the image analysis. So I will demonstrate how the home route is working. We have the form here for the user, and we can choose a photo. I have a bunch of pictures here that I've downloaded before, so let me just use this one. You can put a user description that is not necessarily in English, so I'll write one and just have some coordinates here from my home country. Once you click submit, it will take a little while to prompt the language model with the picture, and eventually we get a successful submission. We get the category from the LLM, and we get the latest entry here at the bottom with the category displayed here, translated description from Spanish to English in this case, the GPS location given by the user, the country given by Nominatum API, the LLM's brief description of the image, and a UTC timestamp. So now let me go over the code structure. So after all my imports, for now I have deleted the API key just not to show it on the video, but this is in this case hard-coded just for this example because it needs to work. So it has been submitted to GitHub. So the code starts by defining our allowed categories. I'm also defining the database so we can call it and initialize the database in case it doesn't exist. So we have a few columns. We have a file path for the images, a category, which is going to be the one that the LLM returns, a user description, which is going to be the translated description, the GPS coordinates given by the user, the country given by the Nominatum API, timestamp, and the short description. So now we also have classify marine debris. This was an old function that I used to test, but the one that is being used is classify with Gemini. So this is the prompt, and I'm asking it to do three things: to look at the picture, classify it, translate the user given description, and so it'll give three outputs. So the first line would be a 5-word description of the image. Second line would be the actual classification of the image. So and then we're opening the image to give it to the LLM, and then we're gonna generate the content from the model with the image as an input of the prompt, and then we're gonna get the full response. And then we're gonna parse that response, so we're gonna get the short description, the category, and the user description in English from the LLM. Now, in this part, I had to add this because I tried the service from my phone and I got an error saying that the image was too large. So one of the ways that I'm addressing that is that I'm trying to cache that error and flash it via Flask, saying that it should be under 10 megabytes. Now let's start looking at my submit method. So as instructed, this is a post method, and this is mostly handled by Flask, which is really nice. So first of all, we're going to check if the fields in our form are all complete, and if not, we're going to require that they are complete, and then we're going to reload home. So after that, we're going to get those values or strings from the form. If the file was selected, we also flash an error, and then we're going to parse those values. And one interesting thing here is that I had to do this unique name format for the images because I had an error that we're uploading the same image multiple times. Um, Sometimes if it got the same name, then it would cause problems either for deleting the image from the database or for uh, acquiring the correct entry. So after getting the values from the form, we send it to classify with Gemini. We get the results, and if it's a none returned from Gemini, then we flash the error saying that it's not a marine debris. We also perform the lookup of the GPS coordinates given by the user. We get the country back, and we can look at that right now. We're using nominating the same way as in previous assignments. And then we're going to save all that information to our database. So these are our fields, and we commit and close. And once that has been done, we can flash that this submission was successful. And there's another very interesting part that I had to add because I wanted the service to be accessible not only via the user form, via web, but also via the API. So in that case, the API will have a header that will say that it accepts JSON, not HTML, and then they will get a JSON format structure with the results of the entry. So now let's look at the home route, and this is mainly handling the form. So we are connecting to the database. We are fetching all the entries in order to be able to show them, and then we parse through them, put them in an entries list, and then allow Flask to render the table in a neat way. So, oh, and also I had to add this little part at the end so that the HTML file that is handling the front end is able to retrieve the pictures that have been uploaded and display them. So the HTML file was largely handled by ChatGPT. I'm not very knowledgeable in HTML, but I did have to add a few things. One of them is a loading animation because it takes a little while for the LLM to respond. So between the time that the user clicks the submit button and the results appear, then I wanted to add a little animation to let the user know that things are going on and that he doesn't need to click again. So this is all just the structure of the web page, and then these are all just the definitions of the bottom form that was being shown, as well as the retrieval of the images from all the previous entries. So now that we have seen the code a little bit, I also want to show how to access the service via just a Python script, and I have my domain here from the INFO8000 with my name. That's just the one that I set up during class, and I'm giving it a photo that I have here. That's just an old can in a beach. So the API needs this header. That's one of the things that I had to implement in order for this to work. I'm giving it a description, in this case in Spanish, just to test the translation capabilities and GPS coordinates. And then we get the response, and as I said, we'll get a JSON structure. So once I run it, we can see that we get a status code 200, meaning saying all it's fine, and we get our JSON response with the category from the LLM, country from the GPS, the description translated, the LLM summary, which is the short description from the LLM, the status saying success, and the timestamp. And we can see that in our service. So once I reload it, we can see that we have our latest entry here, metal old can, with our timestamp that is in UTC. So now I want to talk about a little bit of what I did to deploy the service in a more professional way. So the first step was creating a Python environment in our Oracle server um, that we created in class, and my environment is called Marine environment, and in there I created a local repository where I'm pulling from my GitHub repository all my code. Here you can see all my files. A little detail about this is that the uploads and templates folders, I had to create them manually and give them permissions manually because the Linux wanted permissions for that, so they couldn't get created um, when the app.py started. But after that was solved, I installed the requirements.txt, and that worked. For the most part, I had to reinstall Flask, but that was about it. After that, I also gave permissions for Marine Debris Database because that one also wanted sudo permission, so I had to do it manually. And then I tested it locally. So after pulling all my code, I created an SSH session with port 5000 forwarding onto my local machine, and that worked really well, so I could see my app working. And then it was time to deploy it through Gunikern. So for that, I'm using tmux, install Gunikern, and I'm running it on a tmux session, and you can see here the output from the previous entries. So now it's working and running forever, hopefully. And I also had to configure the Nginx as the reverse proxy. So for that I had to we can look at the Nginx configuration file, and these are the two main things that I want to point out: my domain name and the 10 megabyte size that I had specified in the code previously. So after that, I wanted to allow my domain name to be HTTPS, and I did that via certbot. I installed certbot and then did sudo certbot nginx domain.net, and that kind of took care of things. So, oh, and one last time that I did was configure the firewall of the server. So I used this command that I found called UFW to allow OpenSSH and Nginx full, and then I enable that just to make sure that all the correct ports are allowed and no other ports are open. So that's how I brought my site live, and I finally just want to test one picture that shouldn't be classified as marine debris. So this is a sports car, but I'll try to trick it saying trash. I'll give it some Georgia coordinates, and well, successfully we say no marine debris or unrecognized category. So that's working correctly. We can try other things that are interesting to see how how it describes them. So I like this marine bag. I like to give it in Spanish just to test the translation. Give it some repeated coordinates, and we can see that it accurately describes what it is. It's plastic, and it describes that a plastic bag underwater. And all of this is, of course, being saved in our database.